All right, hello and welcome to the last video in the MSU Denver video walkthrough of the Elementary Calculus Study Guide. In this video, we're going to be talking about factoring polynomials, and I'm actually going to combine it. If you're following along in the study guide, we're on page 35, and page 35, the example problems, what they're doing is they're factoring polynomials, which we're going to go over. And then page 36 talks about solving polynomial equations. And if you watch the other videos, maybe you've heard me say this and maybe not, but the reason we factor is to either simplify things because maybe there's terms that we can simplify and we factor and we see that we can simplify those terms, because before we factor maybe we don't see that we can simplify those terms, but we factor to be able to simplify, and we also factor to be able to solve polynomial equations. And in this test, in this study guide, by polynomial equations, we're talking about quadratic, so just an x squared. We're not going to talk about like x cubed and stuff like that, but that's the other, maybe you'll learn to solve for x cubes and stuff like that, but we're going to get into solving polynomial equations using just x with quadratics by factoring. But the factoring that we're going to do to solve those polynomial equations, to solve those quadratics, is the same type of factoring that we're going to be using on page 35. So I'm going to combine it into one video, and I'll talk about how I factor polynomials, and then I will do example problems, and I'll just do 1, 3, and 5. I'll let you do 2 and 4 on page 35, and then we'll just jump straight into the example problems on page 36, and we'll do some of those as well. But really, the hardest part of solving polynomial equations, of solving them, is in my opinion, is the factoring, right? And so it's really just an extension of what we're going to be doing on page 35. And just kind of to clarify, if you're familiar with algebra at all, and you're familiar with the quadratic equation, factoring is actually a lot simpler, if we can do it, right? We factor when we can factor with whole numbers. And if you can't factor with whole numbers, you have to end up using the quadratic equation, or you can use your calculator or whatever. But this works extremely well, and it eases stuff when it's not when they're whole numbers. But there are times, not in this, they're not going to give you a problem that you can't factor here, but there are times when you won't be able to use this. But if you can use this, it's definitely the easiest thing to do. So let's just jump right into it, and we'll factor. And I'll just kind of come up with my own problem real quick. Actually, I'm not going to come up with my own problem. I'll just use one of the near the bottom of page 35. Before they get to examples, they have a problem that looks like this: x squared plus 5x plus 6. And in these problems, in this instance, there's no reason to factor, right? Like, we're just factoring just to factor, and to get used to it, to practice problems, right? But like I said, like, if this was ever like divided by something else, right? And I don't know what it would be divided by, and I can factor it. Let's call it. Well, let me show you real quick. Let me just do it with letters, right? If I had something like C, right, over, let's say, D, and somehow I can factor C into, say, well, C is the same thing as B times D, right? And that's still over D. And now I can cancel D's out. So what C divided by D actually simplifies to is just B. And so that's a reason you would actually simplify. And you'll go, and I'm not sure that that's going to be applicable on this test at all, but that's why we do that. Or we do it to solve, and we'll get into that in the next page. But how we factor, there's a couple different ways. And I actually do it different than the study guide here. So if you want to follow along in the study guide, if that makes sense to you, by all means, please do that. Whatever way works best. But what I do is I use the x method. And so I draw an x. I put a little dot right there, and I put a plus sign right here. And what goes up here, we're going to put two numbers, one up here and one down below. And what goes up there is this number right here. And a quadratic, right, meaning x squared, we can write it in the form ax squared plus bx plus c. And you'll see this a lot if you take algebra or finite or some business maths. If you deal with quadratics a lot, you'll see this a lot. And where a, b, and c, and a doesn't have to be capitalized. I don't know why I did that. They're just the coefficients, they're numbers. And I say that because ideally, the easiest way to do this is if a is 1, right? And so if a is not 1 and maybe a is 2 and you can divide through by 2, well, do that, right? And make it 1. But sometimes you can't. Like, let's say it was 2 in this case, right? Because if there was a 2 here, I couldn't divide the 5x by 2 and get a whole number back, right? I don't want a fraction, so I can't get a whole number back, so I can't do it, right? So I'd have to kind of work that out. But in my method, and we'll go over that, number 5 in particular, number 4, I'll let you guys do number 4, but number 5 also is like that, so we'll see it. But up here is a times c, right? And so in this case, the example that I just gave, a is a 1, so it's just c, which is 6. And in the bottom goes b, so this is a 5. And if there was a negative in there, like a -5 here or a -6 there, and you keep the negatives in here, right? So these are both positives, so I'm going to leave it like that. And then I ask myself, what two numbers multiply, which is why the dot's there, to get 6, and add to get 5? And this one's easy enough. It's 2 and 3, because if I multiply 2 times 3, I get 6. If I add 2 plus 3, I get 5. And so those are my two numbers. And then what I do is I create a set of parentheses, and I go like this. I write 2 sets of parentheses, and I put an x, or if it's another variable, I would put that. But in this case, it's just x, and I put x here and x here. And this is if it's 1, right? The coefficient if a is 1. And if the coefficient a is 1, then that's simply x and x. And then I throw these in, these two numbers that I have over here. I say plus 2 plus 3, because they're pluses, right? It's a positive 2 and a positive. If it was like a plus 2 and a minus 3, well, then I would put a minus 3 right there, but it's plus. So, and that's it. That's the reason we factor this, right? And again, maybe the reason we might do this is, what if it was x squared plus 5x over 6 plus 6 all over x plus 2, right? That's fine and dandy, but if I can break it up into this over x plus 2, then I can cancel out the x plus 2's, and this was just equal to x plus 3. And so I can simplify x squared plus 5x plus 6 divided by x plus 2 to just x plus 3, and that's a lot nicer, right? And so that's one reason why we might factor something like that. The other reason, again, we'll go on the next page, is to solve. But that's all we're doing, and it gets more complicated, or not more complicated. It gets harder, it gets tougher, But that's the basic idea. So I'm just going to jump right into the problems, and by the time we're done with number 5, you'll kind of have seen like the tough problems. But let's just jump into number 1, and then we'll do the odd problems. Then we'll jump into page 36. So number 1 on page 35. Let me just jot this down. Page 35, number 1. This says r squared plus 8r plus 12. And again, it doesn't matter if it's r or w or x or whatever. It's all going to be the same. And so I'm going to draw my x over here. And again, this is different from the book. So if you're doing it the way that the book does it, that's perfectly all right. Whatever's easiest, whatever's best for you, whatever you can remember. And you should get the same answer, whichever way you do it. So this is our equation over here. And I have my plus, or my multiplication, my plus. My multiplication is just 12, because 12 times 1 is 12. My plus is 8, and I'm asking myself what two numbers multiply to get 12 and add to get 8. And this one's pretty easy, but if you need to, just write the ordered pair, the factors of 12 out. So that's 12 and 1. It's 6 and 2. There's 4 and 3. There's 3 and 4. And once you start repeating it, you don't need to put 4 and 3 and 3 and 4, but you might if one's like a negative. But in this case, it's just 6 and 2. So plus 6 plus 2. It's going to be 8. You multiply and you get 12. And then so I simply draw my parentheses. I'm going to put an r here instead of an x, because we're talking about r's. And then just plus 6 and plus 2. And you'll see that if you distribute this, if you FOIL it out like we did in the previous video, you will end up getting r squared plus 8r plus 12. So that's number 1. Pretty easy. Number 2. Oh, I'm sorry, I'm not going to do number 2. I'm going to let you do number 2. Number 3, I was looking at number 3. K squared minus 11k, again, it doesn't matter what the variable is as long as they're the same, plus 30. I draw my x. My top up here is 30. 30 times 1 is 30. And my bottom is negative 11. So now I got to ask myself, well, what two things multiply to get a positive 30 and add to get a negative 11? Well, since they have to multiply to get a positive number, I know that both of these signs have to be the same. And since they have to add to get a negative number, they both have to be negative. if you'll see this in number 4, you won't see it in number 12, number 5. But if this were like a negative 30, I know that to get a negative 30, you have to have one positive, one negative. So the signs down here would have to be different, right? So just there are little tricks to kind of say, oh well, you know, if it's a positive up top, then they both have to be the same sign. And these are just tips and tricks for this X method, right? Again, if you're going by what the study guide's doing, it's going to be different. But so I know that both have to be negative. And so now I'm asking, like, what two negative numbers add to get negative 11, yet multiply to get 6, and you can, you know, work out the factors, but it's going to be 5 and 6. Negative 5 times negative 6 is positive 30. Negative 5 plus negative 6 is negative 11. And so I just write it out like I've been doing, my parentheses, and then this point I'm going to put K's, and then it's minus 5 minus 6 because it's negative 5, negative 6. And that's it. Those are the factors. If you FOIL it out, you'll get K squared minus 11K plus 30. All right, moving on to number 5, much trickier because the coefficient, the A, right, if we wrote AX squared plus BX plus C, the A is not a 1, and we can't make it a 1. We can't divide through to make it a 1. So what do we do? Well, let me write it out first. 3x squared minus 20x plus 12. I still do my x method. I put the dot and the plus sign. But up top here, again, it's a times c, and a is no longer 1, right? So it's a, which is 3 times c, so 3 times 12, so that's 36 up here. And then the bottom is going to be negative 20. And then I got to ask myself, what two numbers multiply to get 36? They have to both be the same because it's a positive number. They both have to be negative because it's negative 20 down there. And then what are the two factors of 36 that get to 20, where the difference between them is, or when I add them, it's going to be negative 20, excuse me. And that's well, 18 and 2. All right, and you can work out the factors, and it might take you a few minutes to kind of figure that out. But as long as you do, negative 18 times negative 2 is positive 36. Negative 18 plus negative 2 is negative 20. All right. Now, we can't just make our parentheses now, right? The first thing we have to do, and this is where it gets a little tricky, there are different ways to do it from this point, and I'm going to show you the method that I like and that I do. If you know another method, or if you're following along with what the book's doing, by all means, do it that way, whatever gets the correct answer. But here's how I do it. I rewrite my problem as 3x squared. I rewrite that the way it is. But instead of 20x here, I'm writing it as a combination of these two right here. So I'm going to write minus 18x minus 2x and then just plus 12. And if I look at that, excuse me, if I combined a minus 18x and a minus 2x, I would have minus 20x. So all I did was kind of broke up the 20x into two different things. And now what this method I'm doing now is called factor by grouping. So I want to group things. And so what I'm going to do is I'm going to put parentheses around, I'm going to have parentheses around 3x squared minus 18x. And I'm going to say plus, and I'm going to put parentheses around this stuff over here. So I kind of break them up with a plus sign. And so it's plus minus 2x plus 12. And, if I kind of took away the parentheses, it would all be the same. I haven't really done anything. I'm not changing anything, right? Once I'm at this point, I want to factor something out, but not factor in the way I do with parentheses. I'm just pulling out the biggest term between these two and then between these two. So the biggest term in this first kind of grouping here, the biggest thing I can pull out is, well, I can pull out a 3 out of each one because the 3 is divisible by 3 and 18. So I pull out a 3, and I can pull out an x out of each one. So I'm going to pull out a 3x. And what I have left is, in that first term, I just have an x. And, if you need to divide, do whatever you need to do to kind of work through it. And then in my second term, what I have is a negative 6. And this makes sense because if I multiply 3x through that parentheses I just made, I'm going to get 3x squared minus 18. And then I'm asking, okay, well, what can I pull out of this one? And I'm going to pull out a negative 2 as far as the numbers go. I can pull out a negative 2. So minus 2. And then what do I have left? Well, if I divide this first term by negative 2, I have a x. Right? If I divide 12 by negative 2, I have a minus 6. And so now I have 3x times x minus 6 minus 2 times x minus 6. And again, it might look like I'm creating more work, but if I multiply this all out, I would still end up getting 3x squared minus 20x plus 12. But now the nice thing is that if you look, I have an x minus 6 here and an x minus 6 here. And so now if I think about this whole expression about what I can factor out, I can actually factor out, I can pull out an x minus 6 term because each one of the terms have that, right? So if I pull out an x minus 6, I'm going to go like this, x minus 6 in parentheses. And then I ask myself what I have left, just like before. And in this first term over here, again, if you need to divide, I divide by x minus 6. And what I'm left with is 3x, okay? And so what you're always going to be left with is whatever's on the outside right here, and whatever's on the outside right here. And so in this second term, there's going to be a minus 2. But if I had negative 2 times x minus 6, and I divided by x minus 6, I divide out what I pulled out. I just have a minus 2. And so now I'm just left with 2 parentheses, right? And it might seem like that was a lot of work for kind of something silly, like why did we do that, right? But in fact, these are the 2 parentheses that we want, the x minus 6 times 3x minus 12, minus 2, excuse me. And if you FOIL that out, you will get 3x squared minus 12x plus 12. It was a lot of work, but that's mainly because we couldn't get this 3 over here to a 1, like we can divide out by 3. And so that's what you're going to have to do. Well, you don't have to. That's the way I do it, and that's what I enjoy doing, and it's helpful and it's correct. But whether you go by the book or whether somebody else touches something differently that works, whatever gets you to x minus 6 times 3x minus 2, use that. Okay, so now we're going to jump in. That's problem number 5. I encourage you to do 2 and 4. I'm going to jump right into page 36 here. So let me write that down, page 36. And we're doing the same thing that we just were doing, except we're setting it equal to 0. And then we're solving, and we'll get into why and what we're doing there. But if I ever have a quadratic, or really anything else, but in this video for this test, if I have a quadratic, which means x squared, plus other stuff, plus other x's and stuff, or q squared or t squared, whatever. The first thing you want to do is you want to set it equal to 0. What that means is I want to have 0 on one side. So let me write down problem number 1. And I'm just going to do the odd problems in this one. So 1 is x squared minus 6x plus 8. And it's already equal to 0. But you can see if you look through the problems, you want to set it equal to 0. And actually, if you look at 6 and 7 where it's not equal to 0, we're not going to do that. I'll show you what we do. So I'm lying to you right now. I'll show you what we do when we get to 7. But if let me show you this. If I had something like equals all of this stuff equals 5, right? Or equals x minus 2. I'd want to move everything over to one side so it's on 0. And again, I'll show you why we're not doing that for 6 and 7 once we get there. But 90% of the time you want to set it equal to 0 like this. And this is so we can get what is x equal, because I told you before, if we have one equation and one unknown, I should be able to solve for a number, right? And in fact, this is not a linear equation, right? It's a quadratic, but I do have one equation and one unknown, so I should be able to solve for x. There are going to be times, not in this problem, not in this study guide, but you might have imaginary numbers and stuff like that. I'm not going to get into that, but you should be able to get something, right? Because I have one equation and one unknown. And so that's why we set it equal to 0, and this is the other reason why we factor, right? Now the method is still the same. I'm going to factor this. I'm going to use my x method. If you're using a different method, that's quite all right. So up here, the coefficient for a is that's just a 1, so that's nice. So this is just 8. This is a negative 6 because it's minus 6x. I asked myself what two numbers multiply to get to 8 and add to get to negative 6. Again, they had to both be negative because this is a positive up here and this is a negative down here. And then if I do minus 4 and minus 2, and if I'm going too quick, that you can pause and kind of see if you can see that. And I encourage you to actually pause it while I'm doing the x method and see if you can figure out for yourself, even on the problems that I'm doing. But to kind of expedite the video, I talk a lot, so I'm going to try to skip stuff where I can. It's minus 2, minus 4. Minus 2, minus 4, that means minus 6. Minus 2 times minus 4, that's positive 8. And so, again, I can just say x minus, because a is 1, x minus 4, I can just go straight into my parentheses, x minus 2. But it's still equal to 0. And here's the kicker here. Here's the important part, right? The reason why we factor and the reason why we do this is because if this whole thing over here is equal to 0, and I'm telling you it is, and I'm multiplying these two, right, because they're parentheses next to each other, so we kind of imply that, then to get 0, right, the only way to get 0 is if either this is 0 over here or this is 0 or, right? So one of the two, right? If the right parentheses was equal to 0, it doesn't matter what the left parentheses was, right? The left parentheses could be 50 million, and if I multiply that by 0, I'm going to get 0, right? So that makes this equation true. And the same is true for the left parentheses, right? If somehow I can make the left parentheses equal to 0, the right one could be, 0.5. I don't care. It can be anything, right? If I multiply it by 0, I'm going to get 0. And so the goal here is to figure out what makes the right parentheses equal to 0. So I'm going to say, well, excuse me, let's do the left first. X minus 4 equals 0. I'm going to say, when is that true? And then I'm going to make another equation, say x minus 2 equals 0. When is that true? And then I'm going to solve, and this is easy enough. So x equals 4 and x equals 2. And what that means is you have two answers, right? And so this whole equation up here that we started with is equal to 0. I can either plug in 2, right? I'll plug in 2 for x. I'll get 0. I guarantee it. And if I plug in 4 for x, I will also get 0, right? And so if this were a quadratic equation and I graphed it or whatever, it would look something, maybe like, I don't know, like this, right? And at 2 and at 4, and it's not really, accurate, but at 2 and 4, it would cross the x equals 0 line. And that's what, that's a big reason why we solve for this stuff. But more importantly, kind of, if I plug either one of those into the original equation, yes, I'll get 0. But if I plug 2 into when I broke it up right here, what happens is this right parentheses becomes 0. This left parentheses, if I plug 2 in there, I get 2 minus 4, so that's negative 2. But negative 2, again, I don't care what it is. Negative 2 times 0, it's going to be 0, right? If I plug in 4 into this right here, the left parentheses becomes 0. The right parentheses becomes a positive 2, but it doesn't matter what it is. Positive 2 times 0, it's going to be 0, right? So this whole thing is true at x equals 4 and x equals 2. So x equals 2 comma 4, something like that. And that's the solving polynomials part, right? So again, most of the work is all in the x method or whatever method you did to factor it, and then you just set each one of your little factors to 0 and you solve for x, and it's that easy, right? And typically when you're solving, when you set your factors and set your factors equal to 0 and solve for x, that math is typically pretty easy. It's just getting what those factors are, which again we did on page 35. We're doing it again here, but this is more application. All right, so if I'm doing the odd ones, let's jump on to number 3. And number 3 says 3w squared plus 8w plus 8w plus 4 equals 0. And just a quick note, if you're doing number 2, there's different ways to do it, but you don't factor that one. You don't factor using the x method. You're not going to have two groups multiplied by each other. Instead, look at just factoring out the greatest common term that you can. What we're doing, factor polynomials, and is best, or the x method and the method that the book talked about on page 35 is if you have an ax squared plus bx, and I know I've talked about that, plus c, but if you look at number 2, there is no c, right? And so if there's no c, or maybe there's no b, like bx, right? There's no term like that. You're not going to be doing the x method. There's going to be different ways to do that. So look at just pulling out the biggest term that you can. But back to number 3. I am going to be doing the x method for this one. But it's also, I have a 3 as my a, and I can't divide out by 3, and so it's going to be a bit of a long problem like we had in number 5 on the previous page. But up here, again, this is multiplication, this is plus 3 times 4, so this is going to be 12 up here because it's a times c. Down here is just a positive 8. I asked myself, what goes into those two? Looks familiar. It's 6 and 2, and so I can't go straight to my parentheses right now because a is not 1. What I do instead is I rewrite this 3w squared. I rewrite 8w as a combination of the two numbers that I found, so 6w plus 2w, and then plus 4, and then equals 0. I then group it, right? And so I say this is parentheses 3w squared plus 6w plus, and then this is 2w plus 4 equals 0, and then I pull out the greatest common term. In the first term it's 3w. What I have left is w plus 2. And the second one I can pull out a 2, so I'm going to say plus 2, w plus, not 4, 2 equals 0. And now I can see, again, if you followed along in the video, this is kind of the same thing, exactly the same thing, not just different numbers, as number 5 on the previous page. But I have a w plus 2 in each term. I can pull that out, and so if I pull that out, I have a w, oh my gosh, what am I doing? I have parentheses w plus 2 because I'm pulling that out. What's left? Again, you can divide each thing by w plus 2, but really it's going to be whatever's on the outside here. So it's 3w plus 2 because there's a plus there, plus 2 equals 0. And those are the factors of that. And that's the hardest part, remember? If I factored that back out, or if I FOILed that back out, I will get 3w squared plus 8w plus 4 equals 0. But based on what we just did with number 1, what I want to do is I want to set each one of these equal to 0. So I say w equals, w plus 2, because that's that first term, equals 0. And I say 3w plus 2 equals 0. W equals negative 2. And w, well, let's do this in steps. 3w equals negative 2. W equals negative 2/3. And so those are our answers. Is w, let me rewrite that. W equals negative 2 and negative 2/3. All right, moving on to number, let's see, that was number 3. Moving on to number 5. Let's see here. 5. Negative, negative 2x squared plus 13x plus 24 equals 0. And again, I can write this as ax squared plus bx plus c. So I'm going to do the x method. My top number becomes, let's see, 24 times negative 2 is negative 48. My bottom number is 13. I ask myself two numbers that multiply to get negative 38 plus and add to get 13. I know one has to be negative, one has to be positive. The bigger number is going to be positive. And if you do the factors of 48 or negative 48, you're going to get a plus 16 and a minus 3. 16 times minus 3 is negative 48. 16 plus a negative 3, so 16 minus 3 is positive 13. Again, this a is not equal to 1, so I'm going to have to rewrite it. So I rewrite it as 2x squared, and then instead of 13, I'm going to write plus 16x, and then minus 3x. So I get a plus. If I add those two together, it would be plus 13x plus 24 equals 0. Scroll up a little bit, and then I'm going to group it, factor by grouping, right? So this is negative 2x squared plus 16x, and it's plus, and then in parentheses it's minus 3x plus 24. If I said minus and then in parentheses 3x plus 24, that minus would distribute. So you got to make sure you put a plus here and then keep the negative if there is a minus sign right here. Keep that negative, like the minus sign, attached to whatever is in there, because you don't want that negative to apply to the 24 if it's not supposed to. Anyway, this is still equal to 0. I factor out the best thing that I could, and I could factor out a negative 2 or positive 2, but whatever I factor out, either one, or I want to factor out the x as well, but it's gonna kind of depend on what I factor out of the other grouping here. So I could pull out a negative 2, and that's what I'm going to do. And I'm sorry, a negative 2x is, if you want to pull out everything you can. Negative 2x. And so what I'm left with is positive x, and then minus, if I pull out a negative 2x, right, minus 8, plus, and then if I pull out, well, it is a plus, but if I pull out a negative 3 here, it's going to be minus 3. And the reason I do that is because then I'm going to have an x, a positive x, minus 8. And I want these two terms to be the same, right? If I pulled out, if in one I pulled out let's say a positive 2x, and then I pulled out a negative 3 over here. One would be, it would be like the wrong sign on the inside of the parentheses there, and so I would have to kind of pull out a negative 1 as well if I need to. What you have to end up with is that the two of the groupings right here have to be the same, right? This is still equal to 0. Since I have x minus 8 and x minus 8, I can pull out an x minus 8, and so in parentheses I have x minus 8. And then what's left is, well, again, it's just whatever's in here, and so I have a negative 2x minus 3. That's equal to 0. And if I factor this out, I can, just the first term, I have x times negative 2x, and I get negative 2x squared. So you'll see that if you want to do it, if you distribute, I keep saying factoring out, if you FOIL that, you will get the original equation that we started with. From here, I want to, like we've been doing, set each of the factors equal to 0. So x minus 8, x minus 8 equals 0, and negative 2x minus 3 equals 0. And so x is equal to 8. That's easy enough over here. And negative 2x equals 3. So x is equal to negative 3 over 2. So those are our two answers for that one. Let me rewrite it right here. X equals 8 and negative 3 over 2. And I've been saying that the two reasons you want to factor are to simplify or to solve. And one of the reasons you might solve is, if you take algebra, you'll get into this, is to kind of figuring out intervals for range and domain, and when those work and when those don't work, and you'll probably be factoring to do that too. So that's another reason to factor. But in that factoring, you're going to be solving, setting equal to 0 and solving, and so that's part of why we're doing it on this page here. So that's the solving area. That's another reason why you might solve. All right, so I've done number 7. Oh, I'm sorry, number 6. No, number 5. I can't count very well. And I'm going to go do number 7, and then I'm going to call it good, and I will let you guys do number 6 and 8 and the other even problems. If you need any help, please come into the tutoring center. So number 7, and I would encourage you to watch this one before you do number 6, or if number 6 you think you could do it, that's perfectly all right. Do that. But number 7, it's a little bit different, right? Because it's not in the form ax squared plus bx plus c. Now, I could make it into that form, right? I could. Well, let me write it out first. This is 2x minus 3 squared equals 81. So if I wanted to distribute, right, expand that, I say 2x minus 3 times 2x minus 3, and I would expand it out, and I would subtract 81 on each side because I wanted to get it equal to 0. I could absolutely do that. However, there's another way to do it when it's like it. And the reason that what I'm going to do is it works is because there's a square over here on the left, right? We're squaring that, and 81 is a perfect square. And if you look at 6, at problem number 6, 36 is also a perfect square, so it would work the same for number 6. And what I want to do is I want to take the square root of each side. If I take the square root of this side, of the left side, then the square root of something squared is just whatever is being squared. So this is just 2x minus 3. And if I take the square root of 81, you might say, okay, it's 9, right? However, we're getting into the point where you have to realize that the square root of something is plus or minus that thing. The reason is with radicals in general and square root, there's a 2 there. We don't write it down, and I kind of explained this in the radical section. But let's just put 81 here. What I'm asking you is, what number multiplied by itself exactly this many times is equal to 81 or whatever's in here, right? And so you might say, well, 9 times 9, right? 9 times 9, because it's 2 times, is equal to 81. But if you think, what about negative 9 times negative 9? Negative 9 times negative 9 is in fact 81. So either plus or minus 9 work. And throughout every other video we've been doing, they've been just kind of saying, well, it's going to be positive. Just, yeah, I know it's plus or minus 9, but it's positive 9, and we've been kind of going forward with that. And there are times when you have this, and based on how the question's asking it, or what information you're giving, you know if it's plus or minus 9. But you might notice that for all these problems that we have been doing in this video, we've been getting 2 answers. And so if I just said it was 9, I would only get one answer, right? Where that's not exactly true. And if you expanded, if you took 2x minus 3 squared and you expanded that and you subtract 81 from each side to get it equal to 0, and then you did the x method, you would find both of these answers. But if we're going to do it this way, you have to realize that the square root of something is plus or minus whatever that answer is. So this is plus or minus 9, right? And to go forward from here, I can't just say plus or minus 9. I have to break this up into two separate equations. I have to say x minus 3 equals 9 or plus 9, and then 2x minus 3 equals negative 9. And now, like the previous problems, we had two equations, right? We can solve for the x in each of these equations. And so for the left hand, if I add 3 to each side, I get 2x equals 12, and then I get x equals 6. And then I get, if I add on this right hand equation, if I add 3 to each side, I get 2x equals negative 6. I divide by 2 on each side, I get x equals negative 3. And so x is equal to negative 3 or 6, or both, right? And you can check that. If you plug negative 3 or 6 into the starting equation on the left, you will get 81, because whatever you get, if I plug in a negative 3 in there, I get negative 9. But when I square that, it becomes a positive 81. And if I plug the 6 in there, I get 9. And when I square that, it becomes positive 81, right? And so because the squaring is going to make whatever's in there positive, that's why I get just 81 and not like plus or minus 81. But it's important to realize that the square root of something is plus or minus whatever that answer is. And that's how we get both these answers. And again, there are times when we could say, well, the negative 9, that's not supposed to be there, or we get the answers and we say negative, if I'm talking about how much time did it take for, okay, like for instance, if you were watching the word problem video, I dropped the ball, and how long does it take to go to drop 122 meters? Oh, negative 3 seconds. Well, wait, does that make any sense that it takes negative 3 seconds to drop some meter? Like, I'm not looking back in time. So in certain circumstances, negative 3 wouldn't make sense, and you would just say, oh, it's 6. But unless they're giving you specific situations or conditions or whatever, you include both your answers, and so it would be negative 3, comma 6. That's the end of this video. I encourage you to do the even problems. And if you have any questions on anything in this video or anything in the previous videos, please come into the tutoring center. This isn't, like I said in the introduction video, this video study guide is not meant to be a replacement for coming in. It's meant to be just an addendum, right? So something that you can kind of add to your coming into this, come in, work on some stuff, go home, watch these videos, or watch the videos at home, and then come in and say, I didn't understand X, Y, and Z. Can we please work on that? All right. Good luck, and come in if you need us.